Okay, question 9. We're moving on to the applied maths now with mechanics. I think the pure questions in this flashback were really quite tricky, some of them. But I think you'll find that the applied questions, the stats and mechanics questions are more straightforward. So in this question, all we care about is the anti-clockwise moments. The anti-clockwise moments about the point A, which is a hinge. If you look at these, all we need to do is multiply the forces by the distance from A. So it's just going to be 0.3 times by 100 plus 0.75 times by 60, and that's just 30 plus 45, so that would be 75 newtons anti-clockwise. So that was fairly straightforward. And then part B, it says the least value of F to hold the rod in place. So we've got this anti-clockwise moment trying to push the rod in this direction. So, well, I don't know what I did that for. But these anti-clockwise moments are trying to push the rod in this direction, 75 newtons. So what we want to do is to try to stop that by putting a force somewhere along here. It has to be at right angles, it says, and we want the force to be as little as possible. Now, as you know from opening doors or closing doors, the least force you need is when you're furthest away from the hinge. So if you try closing a door by the hinge here, you try closing a door over here, you'll find it a lot harder to do than if you close the door further away, which is probably why the handles of doors aren't right by the hinge. Anyway, the least value of F will be when the force is at B, and it's got to go clockwise to balance the anti-clockwise force we just worked out over here. So in B, we want to work out what the least value of F is for the anti-clockwise forces to balance the clockwise forces. Now we've already worked out that the anti-clockwise forces are 75 newtons, so we did that in part A. The clockwise forces are going to be, what's this distance here? Does it tell us what this distance here is? Oh yes, so it tells us it's 0.9. So 0.9 meters times by F will be the clockwise forces. So to find F, all we need to do is divide 75 by 0.9 and do that on your calculator, and you'll get 83.3 newtons to 3 significant figures.